in January 2020. As the first cases of COVID-19 were discovered and publicized, researchers from all areas of knowledge, and all parts of the world, started one of the largest open scientific collaborations in history. In a few months, the number of publications and resources related to COVID-19 had grown massively, and newer initiatives were dedicated to making all of this research available for the community. One such initiative is the COVID-19 Corpus, a collection of hundreds of thousands of research papers, whose texts are crawled daily from preprint repositories and other sources, parsed, and pre-processed to facilitate knowledge discovery, involving tasks such as entity recognition, relation extraction, keyword detection, summarization, and more. A major challenge in this problem involves finding a semantic representation of the surface text that enables recognizing the meaningful elements while removing noise. According to the task at hand, the semantic representation is often domain-specific and language-dependent, which makes it harder to generalize to novel data. In an attempt to provide a general-purpose semantic representation of natural language, we designed SAT+R, an annotation model based on a small number of ontological and teleological entities and relations. The core semantic element is the triplet conformed by subject, action, and target. This model is language and domain independent, and allows capturing some of the most relevant semantics of factual sentences, including structure, taxonomies, causality, contextual dependencies, and more. Using this model, we have manually annotated several resources. These resources include encyclopedic text, public health articles, news, and a small selection of random sentences from the COVID-19 corpus. The annotation process is very similar in all cases, with a team of non-expert annotators performing the first annotation batch, and a team of expert annotators supervising, merging, and correcting the annotations. In the case of COVID-19, a total of 1,000 random sentences were manually annotated. From this corpus, a machine learning model was trained and deployed on the remaining data. Afterwards, the most common entities and relations were collected and summarized in a knowledge graph, semi-automatically constructed. Examination of this knowledge graph shows that relevant facts are discovered about COVID-19, its causes and major symptoms, and even some plausible interventions. However, this work is only an initial step in what we consider a possible process for automatically discovering scientific knowledge in technical text. Moving forward, we recognize two main areas of development. First, the annotation process is the most significant bottleneck in the whole pipeline, and its quality is crucial to guarantee that robust models can be trained on annotated data. To improve this element, we are exploring active learning strategies, in which the annotator interacts with an incrementally trained model, that can help both in suggesting which sentences are more informative, and by automatically pre-annotating some of the entities and relations. Second, the machine learning model itself is still insufficient to achieve near-human performance. We have found that relation extraction is the most difficult task, and that state-of-the-art language models are still far from optimal performance. We have also discovered that knowledge-based strategies can help, if combined intelligently with a powerful statistical model. In this sense, we are exploring AutoML techniques that allow exploring a vast range of different learning architectures. The main lesson learned from this work is that a powerful semantic representation enables the construction of knowledge graphs with the most relevant facts. However, extracting that representation from natural language is hard to automate. Even when applying the most recent NLP techniques, it is still an open question how to best balance knowledge-based approaches with state-of-the-art statistical learning models. But we believe the best direction forward is by intelligently combining these two approaches.